Hi, and welcome to our WebRTC Fiddle of the Month. And this time, because it is becoming more of a fashion these days, we're going to talk about spatial audio, or 3D audio, or whatever. So, what we mean by that is the fact that instead of getting mono and the same audio on both ears, what we're going to get from our speakers, especially on headsets, is different channels in each ear. And with that, we can provide 3D sounds or the impression of people speaking from different locations. Philip, let's go for that.
Yes, let me share my screen. So we're going to use WebAudio, the WebAudio API to implement that, and it's quite a simple fiddle. What we have is a couple of buttons, an audio element, of course, a button to start the capture, a list of these devices, because we will need to select a device like this one to hear it. And we have a control which has a range from -1 to 1 for left to right panning. So we start with a WebAudio audio context, and we create two nodes. One is a stereo panel node, which allows you to add a weight to the stereo channels. So you can do pan to the left or pan to the right. And we have a destination node, which is a media stream destination node, which you can then use again with a element. And we connect the pan node to the destination node and set the audio element source object to the destination node stream element. So let's look at the stuff at the bottom first, which is very simple. We have a list of audio outputs, and if that changes, if we change that here, which we can do after we have permission, we can change the audio output destination to select the right device using the setSync ID API.
Okay, so essentially what you're doing is taking the local microphone and then just shoving it to wherever you want in terms of making that stereo and deciding what weights to give to each ear.
Yes, so let's walk through that. We have the button, we disable it, we get the stream from get user media, which is typically not what you would do, because you would do this operation on a remote stream.
Okay.
And then we need to deal with autoplay, because browsers and web audio is quite sensitive to autoplay issues. And we create a media stream source node, which is a way to get the media stream or media stream track into web audio. And we connect that to the pan node, so we go from the source node to the pan node to the destination node. And then we get devices, and we're done. So if we try that, it's a bit, you need to try that yourself, because I can't make you hear what I hear. So I press that button and then very quickly need to select the right output device. So now it's coming from my headphones. And it's currently panned to the left, so I'm setting it to the middle. So I'm now hearing it on both earphones. And if I move it to the left, I will hear my voice mostly from the left, but a bit from the right. But it's, you can hear how it's different volume on each earpiece. And you can play around with that to the right, then it comes mostly from there, and so on.
Okay, so this isn't really how we would use it. And in real life, my guess is that what we'll do is we'll receive from the SFU multiple audio streams. And then instead of just letting WebRTC mix them on its own, we would use this approach and this type of code to mix these two or more streams and decide where they should come from?
Yes, it might depend on your video layout. For example, if you have a layout like we have here, you have one big speaker. But what if you have a grid view with 3 or 4 speakers side by side?
Mhm.
Then you can make some come from the left, some from the right, and that might feel more natural.
Okay. And again, I guess the biggest limitation with doing that and with spatial audio as a whole is that I actually need a headset for that.
Yes. And to make things more fun, Bluetooth headsets don't work well with stereo audio, which is a limitation of the Bluetooth profiles.
Mhm. Okay. So thank you for this, and see you all in our next Fiddle of the Month.